Hey guys, what is up? Tell me in the comment section below. Today I'm going to be continuing on my series on the cross product. Right now we're on part 2. Today we're going to be talking about determinants. So if I say I want to find the determinant of A1, A2, and B1, B2, which is denoted as that means the determinant of something, my solution will be A1 times B2 minus that over there, A2 times B1. And you could also denote this as the determinant of A vector, B vector. And it's important to notice that the answer to the determinant is not a matrix, is not a vector, unlike the dot product. The determinant is actually a number. So let's go ahead and do an example. If I say, what is the determinant of -3, 1, 4, 2? The answer would be -3 times 2 minus 4 times 1. -3 times 2 minus 1 times 4. And that is -6 minus 4, which is -10. Now, another thing we can do, which is more common, is by using a determinant of order 3. That means that it's a 3 by 3 thing instead of the previous 2 by 2 that I just showed you. So if I have A1, A2, A3, B1, B2, B3, C1, C2, C3, I want the determinant of that. I could also write it as the determinant of A vector, B vector, and C vector. My answer will be A1 times the determinant of this over here minus A2 times the determinant of that outside over there in the second and third levels. And then plus that A3 of that square over there, the determinant of that. And we could even go ahead and expand this out further so that you can really get the full gist of what it is. So it would be A1 times B2 times C3 minus B3 times C2 minus A2 times B1 times C3 minus B3 times C1, and then plus, last but certainly not least, A3 of the determinant of that over there, which is B1 C2 minus B2 times C1. And so those over there are equal. That and that, which is also equal to that. We can do a bunch of equal signs if we want. And so another thing that we could want to do is find the determinant among two vectors. And so we'll put in the coordinates for the first row for the x, y, and z components, otherwise known as the I, j, and k components. So I could say the determinant from I, j, k of A1, A2, A3, B1, B2, B3. And what will come out is I'll have I times the determinant of that, j times the determinant of that, and k times the determinant of that. And that'll just give the cross product of this some direction, some knowledge of the axis. So again, going over what the cross product does, that is my 3D plane. If I have some vector A over there, some vector B over there, the cross product finds some vector C that makes a right angle with both vector B and with vector A. And so I could go ahead and solve this. I'm going to, when I do this, again, you can denote this as A vector cross B vector. So whenever somebody writes that, that is what they mean. And one other thing I like to point out is the direction that the C vector goes in. Because how do you know whether the C vector from the cross product points upwards perpendicular or downwards perpendicular? And to find that, we use the right-hand rule. So it's important now to say that A cross B is not equal to B cross A. And so if I say this over here, where this is A and this is B, and I want to find A cross B, again, A cross B, what I would do is I would put out my hand using my right hand. If you're left-handed, which I am, make sure you still use your right hand. And you would have to curl your fingers towards the B vector. And I see that my thumb is pointing upwards. So in that case, A cross B would, of course, equal that C vector over here pointing upwards. But now if I do B cross A, well, now, again, taking my right hand, I need to go from B to A, and I'm curling my fingers towards A. And I can't do it that way. That doesn't make any sense. So I have to turn my hand around and curl it. And as we can see, my thumb is pointing downwards. So it'll be this downwards vector over here. And they're pointing different directions. I'd just like you guys to see that. So I'm going to do an example. We are asked to compute, here I'll say if A vector equals 1, 3, 4, and we have B vector having the components of 2, 5, 6, we need to find, and we're asked to find what vector is orthogonal or perpendicular to this. We would again do the cross product. In this case, we would have to have I, J, and K be in there on the top row to tell us how far each different plane needs to go, each different x, y, and z coordinate needs to go. So I just plug them in. And I'll get 3, 6, not 36. We get 3, 6. Oh, what am I saying? Here, let me write it over here. I'll get I times the determinant of 3, 6, 4, 5 minus, don't forget that minus there, every other alternates. J times 1, 2, 4, 6 plus K times 1, 3, 2, 5 over here. And I can go and do this out. I'll get 18 minus 20, negative 2i. And then this is 6 minus 8 minus 2 plus 2 plus 2j. And then I have 5 minus 6 minus k. So that would be, so the components of my C vector would be minus 2, 2, and negative 1. And now you should have a pretty good grasp on what the cross product is. I'm just going to go ahead and do one more thing. If I'm going to basically prove that the vector A cross B is in fact perpendicular to that vector A. And if you remember from the dot product, if two things are perpendicular, then that means that if they're perpendicular, then their dot products will be 0, because then their cosine of theta would be 0 because that theta is pi over 2. So I need to compute A times, or A vector times A cross B, and that comes out to be A1, the determinant of so I can go over here to say it, or A2, A3, B2, B3, minus A2 of A1, A3, B1, B3, plus A3 of A1, A2, B1, B2 over here. And if you go ahead and multiply this all out, we're going to see that it becomes 0. So I'm going to say A1, A2, B3 minus A1, A3, B2 minus A2, A1, B3 plus A2, A3, B1 plus A3, A1, B2 minus A3, A2, B1. And now I need to look for common terms. I see that I have matching up all of these over here. That's a positive, that's a minus. I can cross them out. Looking for B3. I see that those two match over there. One's a positive, one's a negative. And then these two also match over here. So that ends up being equal to 0. So that right there just proved that the cross product holds true. Thank you much for watching, and goodbye.